So this is going to be the second half of section 7.2. Law signs, you have to watch out for this ambiguous case. So we don't do it day one, we just stay with the one triangle or the no triangles, but we introduce this on day two. Really, anytime you're finding angles, you're going to have to check if two triangles can be drawn. So anytime you have an angle, side angle, or a side angle, angle, you don't even have to worry about it, because with law of sines, you have sine of angle and sine of angle already plugged in. You're finding a side, and a side can only be one measurement. But when you have the side-side angle, you're going to have to check to see if two triangles can be drawn. So as we looked in the book, you can have these goofy situations where one of the sides is set at 8, an angle set at 35, but you can have two triangles here with these dashed lines. So meaning the angle measurements work out, that you're allowed to have two triangles. And then what's going to happen is on one triangle you get a really short side here. On the other triangle you get this huge side right here. But this 6 swings through, and it can be that length to form either of those two triangles. So first, let's review a no triangle case. So this would be, you're given these measurements. What I always do, I look for, B and a B, A and a A, C and a lambda, set those up, and when you get here, you can inverse it in your calculator. Anytime you get something bigger than 1, you're not going to be able to do that, so there's no triangle. Meaning this length of 3 across from a 50 isn't going to be enough to come down to reach this side. Okay, so that'll always pop up in your calculator as a no triangle. Now if you have something like this, so let's say B is 5, C is 3, and angle beta is 30. I don't worry about pictures so much because I don't know how they look, and if you draw them not to scale, it can confuse you a little bit. So there is a picture that the book provided us there, but I just look at what's given and then just kind of tackle the problem from there. So when I see those things matched up, I'm going to say sine of 30 over 5. That means I have to do sine of lambda because I have C equals 3. So we get here. I would encourage you guys to do this work in your calculator as well, so you're getting the keystrokes down. So I come out with sine of lambda equals 0.3. So I'm solving for a lambda here. So second inverse shortcut is hit second negative sign, and that'll just import that answer right in there for you. So I know lambda is going to be 17.45 degrees. I'll just call it 17.5 degrees. Now, before we check for that second triangle, let's just solve everything else here for this triangle that we know. So we know beta, we know lambda. Let's easily find alpha. So again, we can use that shortcut. Minus 30 degrees. That means alpha is going to be 132.5. There's going to be one other thing we're going to have to find, and that's going to be side A. So I need to take sine of A over side A, and then I can pick and choose. I always stay with what's given, because if you did this one wrong, then this next one's going to be wrong as well. So I'll stick with the B's here. So sine of 30 over 5. So I'm going to cross multiply here. So sine of 132.5 times 5. And then I'm going to divide this by sine of 30. So 7.37. Now I always pause here and make sure everything makes sense. A is my biggest angle, so that means A should be my biggest side. That matches up. B is the next biggest angle, so that should be my next biggest side. That works. And then the same for C. Now, that's going to be triangle 1 right there. Now we need to come back to when we had this. Because we're solving for an angle, we need to check and see if it can happen again. Sines are positive in quadrant 1. Sines are also positive in quadrant 2. When we inverse this for C, we said that theta has a value of 0.3 at 17.5 degrees. So that should also mean it's the exact same thing over here with the reference angle of 17.5. But in order to get there, that's going to be 180 minus the 17.5. So 162.5. So basically what you're doing is you're trying to say, can lambda 2 be this many degrees? So then you always go back to the original and check. So if lambda 2 is 162.5, there should be room for a third angle. So if we take that 162.5, we add the original 30 that we were given, we're already over our allotment of angles, or I'm sorry, degrees in a triangle, so that can't happen. So this is a case where there's only one triangle. Now let's look at another one where there's actually going to be two triangles here. So here's the givens, B and a B, so automatically match them up. Sine of 45 over 8. C has to go on the bottom here, so this has to be sine of lambda up there. So sine of 45 divided by 8, multiply across by 10. Okay, so sine of lambda 0.883. So we need to inverse this to figure out where the sine has that value. Second inverse, you can use that shortcut, is 62.1 degrees. Now I don't want you guys to round too much here because it's going to affect answers as you're finding these next three. So do try and keep a decimal place or two. So we'll call this 62.1 degrees. Now we're just going to solve this as we would normally. So we have that. We have an original 45 that's given to us. Take that away from 180. So that means our missing angle's got to be 72.9. That's angle A. The only other thing we need to find then is side A. So we'll set up a ratio. Again, I'm going to go with what's given, because if I screwed up C, then this is definitely going to be wrong. So I'm going to use the two things that are given here. We'll solve this. Okay, 10.81. Now take a minute, make sure everything matches up. Does your biggest angle correspond to your biggest side? That's going to be A's. C is slightly less than that. So C is a 10. So angle C is a little bit less than 72. That's good. B is the smallest angle and also the smallest side. So we're good there. So all of this is triangle 1. Now we need to check if we can make a second triangle out of this. So can that side swing? Can that 10 swing through like we had in the book? So we go back to the first thing we found, and that's when we get here. So we inverse 0.883, we found it was 62.1 degrees. Now the sine is also positive over in quadrant 2. With a reference angle of 62.1. It's the same place. So we want to figure out this huge angle right here. That would be 180 minus the 62.1, and it's 117.9. So we're trying to ask if lambda 2 can be 117.9. We go back to the original that we're given of 45 degrees. That can't move. So can you take 117.9, add on a 45, and is there room for another angle? There is, so that means alpha 2 is going to be 17.1. Now, the only other thing we have to find now is what the side of the second A is going to be. So we set up a ratio using the stuff that we have now. So sine of 17.1 over what we're trying to find. I'm going to use what's given again, sine of 45 over 8, and we solve this. So you can see I did not close my parentheses up here, but I knew something was wrong because you're not going to have a goofy answer like that. So I did not close the parentheses up there. So I can fix that. Sine of 17.1, close that up, multiply it by 8, divide it by sine of 45. Okay, 3.23. So then you're going to tell me all this information here is triangle 2 because that other angle fit. Now you want to go back and double check and make sure it at least makes sense. So now lambda 2 is 117 with the side of 10, alpha 2 is 17 with a very small side of 3, and then beta is going to stay in the middle. So that can work. All right, coming back to what we had in the book then. So similarly, our side of 8 is going to stay. We had a 45, they have a 35. That's going to stay. That side C of 10 is going to swing through. And you can see what it's going to do. So one time, you're going to have a really, really small A here, which is exactly what we have happen. A is 3.23, and a huge value for C, 117.9, which is going to be that huge angle right there. Now, another triangle, we should have a bigger value for side A and a much smaller value for angle C. So A goes to 10.81. That's when it comes all the way across here. And then that angle C reduces to 62 because it's acute now instead of that big one that's obtuse. So when you're doing these ambiguous case problems, just solve triangle 1 like you would normally. Go back to where you inversed it, see if it'll fit in with the given, and if it does, solve triangle 2 and keep them obviously separate. Okay. I'm also going to put some YouTube videos up here where people have different manipulatives and computer programs that kind of show these sides swinging through. That may be helpful to look at. You can look at that example 4 in your guys' book. It'll talk you through how to do a 2 triangle example there, and we'll practice those again tomorrow in class.